Welcome to Getting a Grip on Logs, Part 2. Let's just review some of the properties of logs from Part 1. This was a log once, but I chopped it up and turned it into a garden seat. So if you ever want to come to Western Australia and surf the best beaches and drink the best wine, you can go sit on my log seat. But in a few years you'll have to fight me for it because that's where I'll be. So remember, the log of a negative number is undefined because there's no power of any number that'll give you a negative result. And the log of 0 is also undefined for the same reason. And don't forget, log base b of b to the power of x is equal to x. Let's look at the laws of logs. And here you can see me being brave on a log, but you're not going to see me fall off. So we'll start with the product rule, and I've written it like this because that's how you're going to see it in your formula book. And in blue you'll see the related indice laws, which you don't get in your book. So that was the quotient rule that you can see right now. And don't forget this one, which is the power rule. So if you can't remember these or you've forgotten what they're about, go back to part 1. And don't forget the very important and very useful rule, the change of base rule, because you're not always going to get everything in the same base. So it's important that you understand how to change the base when you really need to.
Hey Skippy, we should probably do some warm-up practice before we move on to some hard ones. Come here, what do you think? You're good at jumping over logs? No? Okay. But I think the rest of us need to do some warm-ups, so here we go.
So express each of the following as an equation that does not involve logs. This is your warm-up questions before we move on.
This is boring.
You sound like Christoph.
Who's he?
Never mind.
I totally understand what you're saying because we've just been manipulating numbers, but logs are everywhere. Anything to do with magnitude or growth or creating scales to represent big or small numbers. So it's really important to get a grip on them so you understand what's going on.
You've got the Richter scale, which represents the magnitude of earthquakes. Then there's the decibel scale, which is a logarithmic scale that shows the intensity of sound. In computer science, you need to be an expert in log base 2 for all the work you need to do. And music, did you know that? In chemistry, measurement of pH is on a logarithmic scale based on the number of hydrogen ions. And in finance, you need a logarithmic scale to show significant changes in stock prices. And I need logs to figure out how much longer I need to save in order to have enough money to retire.
Logs are awesome.
So let's get back to this very short practice exercise, shall we? So pause the video and then see how you go. I'm going to go through these answers fairly fast, so get ready.
Question 1 uses the product rule. Log base 2 of x is equal to log base 2 of y times z. Therefore, x equals yz. Question 2 uses the power rule. Log base 10 of y is equal to log base 10 of x squared. Y is equal to x squared. Number 3 uses the product rule. Log base 2 of x plus 1 equals log base 2 of y x. X plus 1 is equal to y x, or x y. X plus 1 over x equals y. Question 4. Y plus 1 is not a log, so use your knowledge of exponents. 2 to the power of y plus 1 is equal to x. Log base 2 of y is equal to log base 2 of x to the power a half. Y equals x to the power of a half, or the square root of x.
So how did you get on with your warm-up questions? Are you ready for the big time? You ready for double trouble? I'm going to jump straight in and give you one of the toughest questions, which was on this year's paper, paper 1, May. So it's quite tricky. Be warned. You'll notice that there's 2 different bases here, so you're going to have to change the base to start with. Alright, pause the video here and give it your best shot. Before
we start, here's a reminder to keep your work very neat. Keep the equal signs underneath each other so the examiner can see clearly you're working out. Because if you make a small mistake under the exam pressure, you're not going to lose all your marks, so make sure you keep it very clear.
If you came up with a solution of x is equal to -3, very well done. You can skip now on to 9 minutes 50. If you didn't get x is equal to -3, go through the working out that I'm going to show in the next frame. Perhaps you only made a small error along the way.
I hinted to you that we need to change the base here, so I'm going to change this to log base 4. So take the original number and then you need to find the log of the old base. So that was 16. Now look carefully at this number here. This is just equal to 2 because we know that 4 to the power of 2 gives us 16. So now I can just rewrite that and put this all over 2 because that's exactly the same as that. Now this side is divided by 2, so I can just cross multiply and multiply, put 2 times this on this side. So you see I've multiplied this side by 2. Now this should show you that you can now use your power law by putting this 2 and making 2 minus x squared. So using the power rule, I just moved this 2 to create this as x squared. So now I can see that I've got the same base here, so therefore this must be equal to this value. So just let's pull that out now. 2 minus x all squared is equal to 13 minus 4x. This is now starting to look a little bit easier. So let's start with this side. 2 minus x all squared is going to be 4 minus x squared. Whoa, don't make that mistake, everybody. This is really 2 minus x times 2 minus x, which is very different. So let's use FOIL, even though this is not too difficult. So firsts are 2 times 2, that's 4. And then we go outsides, 2 times -2, that's -2x. And then inside, -2x. And then finally lasts plus x squared. Simplify that. Let's put that together. 4 minus 4x plus x squared is equal to 13 minus 4x. Well, I've got minus 4x on both sides, so they cancel each other out. So I actually end with 4 plus x squared is equal to 13. So subtracting 4 from this side, both sides, I end up with x squared is equal to 13 minus 4, which is 9. Yay, this looks really neat. This is telling me that x is equal to 3. Danger. Do you get the danger here? Warning, warning, warning. What's going on? Is that correct? Now look very carefully up here at that. If x was going to be equal to 3, this would be 2 minus 3, which is equal to -1. But we know that we can't have log of a negative number. So what's going on? Where have we gone wrong? Going back over my steps, I'm very happy with that and that and that and that. But this is the problem area here because x squared is equal to 9. This could be, x could be plus or minus 3. Now we've discovered that it can't be 3, therefore x must be equal to -3. That is the correct answer. But it wouldn't hurt to just double check. So let's just move this up there and look at the original equation again. Now let's substitute in -3. So 2 minus -3, that's going to be equal to 5. And 13 times minus 4 times -3, that's going to be equal to 12. So now I've ended up with log base 4 of 5 is equal to log base 16 of 25. Okay, well, let's change this base to 4 again and see what happens. So using the change of base rule, I'm going to find the new base of that, and then the old base of base 4. So, and this is just the same what we were working with before. We know that 4 squared is equal to 16, so all of this is equal to 2. So let's substitute that back in and move that around, all over 2. And again, I can cross multiply that. And now I can use the power law to put this as squared. So now I've ended up with log base 4 of 5 squared is equal to log base 4 of 25. And that is the same. Log base 4 of 25 is equal to log base 4 of 25. So you can see x is definitely -3. Phew, that was a really tough one. Well, if you got that, or at least understood it, you're doing really well, because that's about as hard as they get. The next 3 questions are not as difficult, but are also from past paper 1. So give them a try. I'm sure you'll do fine.
That's a gnarly old fella.
I hope you're talking about the log. Here are the solutions. If you got them all right, you can skip through to the end at 14 minutes 20 for a very cute announcement. Otherwise, keep watching to see me work through the problem so you can try and figure out where you slipped up. For question 1, this is very significant. Okay, we need to, because otherwise we're going to have a problem here. So keep that in mind. Now, I'm going to use the product rule on this side to start with and bring these terms together so that I've got log base 2 of x times x minus 2. But on this side, I don't have a log. So how could I possibly express that as a log base 2? Well, that's not so hard because 2 to the power of 3 is actually equal to 8. So I could rewrite this as log base 2 of 8. That's the same thing. That's 3. Now that I've got the same base, I can see that this value must be equal to 8. So rewriting that, x times x minus 2 is equal to 8. And let's expand those brackets. Is equal to 8. Hello, look at that, we have a quadratic, so let's put it in this form. X squared minus 2x minus 8 is equal to 0, and factorize it to find out what x is. So what I'm looking for is a number that multiplies to give minus 8 and adds to give minus 2. So this means my minus number is going to be the bigger one, so minus 4 and plus 2. Looking at the solution, in order for this to equal 0, x must be equal to 4, or x is equal to negative 2. But we know that this is not possible because otherwise we would have a negative log and that would be undefined. So the answer we're looking for is x is equal to 4. A of question 2 is quite easy because we know that 2 to the power of 5 is equal to 32. So that's the answer here, is simply 5. Now part B is much more complicated. Now you can tell straight away that this is going to involve the power rule because we've got some numbers here in the log of powers. So, but it's also going to be looking at the quotient rule because we've got here. So let's rewrite this first of all as log base 2 of 32 to the power of x minus log base 2 of 8 to the power of y. Now we can apply the power rule because we've got this here and this here. We can just multiply that onto the other side. So this is the same as x times log base 2 of 32, and this is y times log base 2 of 8. Well, in part 1 we already found out what this is equal to 5, and we know already that this is equal to 3. So let's just put that in there. This is equal to x times 5 minus y times 3. Now let's turn that around so it looks a bit neater. 5x minus 3y. So there's your p, and here's your q. So p is equal to 5, and q is equal to negative 3, and that's the solutions. Question 3, I'm going to express this in terms of p and q. Well, I can look at the product rule here because that's the same as saying log of a of 2 times 5, and then that would be equal to, using the product rule, that's equal to the log base a of 2 plus log base a of 5. And looking up here, we know that that's q plus p, either way around really, but that's how you're going to express that value. Here I can use the power law as well because I know that 8 is 2 to the power of 3, so I can express this as log base 2 of 2 to the power of 3, and then I can put in the power law, so I can bring this 3 across here and say that this is equal to 3 times log of 2 base 2, and this we know is q, so the answer here is 3q. I'm running out of space for C, but we can see that this one is going to involve the quotient rule because 2.5 is half of 5. So this you could write this as 5 over 2. That's 2.5, right? So now using the quotient law, this is the same as log base A of 5 minus log base A of 2. And this is P minus Q, and that's that answer. Okay, well done if you got this far.
Hi. Once again, thanks for watching. Now go crazy!